Well, welcome back, and today we're going to discuss doing manipulations with algebraic systems to solve them algebraically. And there's a couple of methods that we are going to employ to solve linear equations algebraically. We're going to start with a simple general two-variable system, all right, in two equations. Okay, now we know that a linear equation in two variables has this general form here. So let's suppose we have two of them, all right? So a single equation by itself, we consider it a system with one equation and two variables here, x and y. So now we have a little bit more difficult system because we have two equations with two variables, and the variables being x and y. So we know that we can write the linear equation in this form here. This is our standard form that you know about. So a good rule of thumb is always move into the standard form. Now with the substitution method, sometimes you can make a bit of a shortcut to that because the substitution method employs writing one of the variables, whether it's x or y, in terms of the other variable and then substituting that back, right, into the other equation. So if you find this y here, then you can find this y in terms of x and then substitute that back up into here, and then you have one equation with only one variable which you can solve. So let's look at the method by which we do this in the general form. Notice that we have a1x plus b1y is equal to c1. We can rearrange this and say, well, this would be b1y is equal to negative a1x plus c1. So I've put the a1x on this side. Therefore, I can write y is equal to negative a1x over b1 plus c1 on b1 when we divide everything through by b1. I now take this y and I look at the second equation, and what I can do now is, in place of y, I can put here's our b2. I'll use parentheses, so we have a negative a1x on b1 plus c1 on b1, and this is equal to c2. Now, even though that looks a little complicated, you'll notice here that in fact we have only the single variable here, and this will just now allow us to go ahead and solve for x. An example will demonstrate this much more clearly than just using the symbols. So let's look at an example. This is the same example that we did graphically. So we know what the answer is, and let's suppose we want to solve this linear system of equations. We have two variables and we have two equations. So we can first of all say, well, let's suppose that we have this equation here. This is equation 1. Let's label it 1. And this one's number 2. It's a good policy to start labeling your equations as you start to manipulate these algebraically. So in this case here, you'll notice that if we look through the equations, we see that this one looks like it's pretty easy to manipulate. So what I could do is I could say, well, equation 2 can be written as, notice here that if I isolate x, I could write this as x is equal to y plus 4 by simply adding y to both sides here. Alright, so notice that I have x now in terms of y. Then what we do is we substitute this x into equation 1. Right, so what we have here is that we have y plus 4. Right, so let me put the equation here. So instead of x, I have y plus 4. Subtract 2y is equal to 2. Okay, now notice that we have only one variable, which is y, so we're going to have y minus 2y is negative y, plus the 4 is equal to 2. I can subtract 4 from both sides, so I get negative 4 is equal to negative 2, so this tells me that y is equal to 2. Right, now, final step here is we need to now find the corresponding x. X value. Right, so we can do that simply from here. Right, so we have that x is equal to 2 plus 4, which is equal to 6. So our solution then, right, is the point 6, that's what x is, always goes first, and then 2, which of course is the 0.62, and that's our solution set. Okay, and you can see that we've got exactly the same result. Right, the next method we're going to talk about is called the elimination method, and this is a very popular method. Now, the elimination method means to change equations so we can eliminate a variable. Okay, now there's a couple of things that we need to keep in mind here. Right, let's suppose that we have two equations, a1 x plus b1 y plus c1 and a2 x plus b2 y make it equal to 0 plus c2 is equal to 0, for example. Now notice that if I wrote them in the reverse order, we'd have exactly the same system. So the first thing to note is that we can change the order of the equations. Right, and that does not change the solution whatsoever. Number two, if I was to multiply one of these equations through by 2, we would still have the same equation, it's just that the coefficients and the constant term here would be doubled. So the solution wouldn't change, and so we can multiply equations by non-zero constants. Now I say non-zero, right, because if we multiply through by 0, then we just have a 0 equation. That's not helpful at all. And thirdly, all right, we can add, all right, or subtract, it doesn't really matter, multiples of one equation to another equation. So in other words, I could take the product, multiply one equation here by a non-zero constant and add it to another equation, all right, to form a new equation. These are what we call row operations, because we've got our equations in rows like this. So we can change the order of them. We can multiply any particular equation by a non-zero constant. All right, and we can add a multiple of one equation to another equation to form a new equation. This does none of these operations, and we'll call them equation transformations if you like, will affect the solution of the system at all. And so elimination then will allow us to apply any of these equation transformations, if you like, to remove one of the variables. Okay, now notice, if you will demonstrate this using an example, that'll make it much clearer. Right, so we have the same system here. All right, notice that we have x minus 2y equals 2, and we have x minus y equals 4. Now, notice if I label these, let's call this number 1, and this is number 2. So the first thing, step 1, we'll notice that we have an x and an x here. So if I was to multiply number 2 by -1, what would I produce? I'd get -1 by x minus y would be equal to -1 by 4. We've got to do it to both sides. So I'd end up with -x plus y equals -4. And I can call this equation 3 if you like. So if I now look at equation 1 being our original equation 1, and now my equation 3 being -x plus y equals -4, then what I'm going to do is I'm going to add these two. So that'll be our step 2. Right, now when I add these over, x plus -x is 0x. Okay, so then I have -2y plus y gives me -y. And that's equal to 2 plus -4 gives me -2. I can now have this new equation here. I have y is equal to -2, which means that y must be equal to 2. Right, now step 3, right, substitute y equals to 2 into either equation 1 or 2, it doesn't matter. Right, so if I look at my equations, here we have it, y is equal to 2. I'm going to use it in equation 2. So let's choose equation 2 to do it in. Then we have x minus 2 equals 4, which means if I add 2 to both sides, this implies then that we have x is equal to 6, which is what we had before. So our solution then is going to be again the ordered pair 6, 2. Okay? So that's using elimination. Let's do it on a slightly more difficult one. Alright, so again, using the elimination method, let's solve the linear system of equations. 9x minus 5y equals 1, and -18x plus 10y is equal to 1. Alright, so we look through this and say, which ones are easy to change? Well, notice that we have a multiple of 2 here and a change in sign. So when I label this, this is number 1 and this is number 2. Alright, so step 1. Alright, I'm going to take equation 2, so we get multiply equation 1, alright, by 2, okay, with the objective of actually adding it to equation 2. Alright, so our new equation is going to be 2 times 9x minus 5y equals 2 times 1 over here. So I'm going to get 18x minus 10y equals 2. So this is our new equation 3. Alright, so step 2, we're going to add equations, that's 3 I should say, equations 2 and 3. Okay? Because remember we changed equation 1, so we don't want to be adding it to equation 1. So alright, what we have now is 18x minus 10y equals 2. And we have negative 18x plus 10y is equal to 1. So we're going to add these two. So notice here I get 0x here plus 0y here is equal to 3. So of course anything by 0 is 0, so I've really got 0 plus 0 equals 3, or 0 is equal to 3. Now that raises a problem. When is 0 equal to 3? Well, this is never true. Okay, so this is an inconsistent system. And so the solution is the null set. Okay. Alright, so there is no solution, right, because we have this inconsistency that we know that 0 is never equal to 3. Okay? Alright, let's try another one. Right, in this case here, let's use the elimination method to solve the linear system of equations. 3x minus 2y equals 18, and 2x plus 3y equals negative 1. Now notice that we haven't got really a good set of numbers here. It looks like we're going to need to change both equations by finding a least common multiple for these two equations. Now notice that if I multiplied number 1 by 2, I'd get 6 here. Alright, and if I multiply this by 3, I'd get 6 here, but they'd both be positive. What I do notice is I have an opposite sign here, so what if I was to multiply equation 1 by 3, that would give me a 6 here, and this one by 2 give me a 6 here, but they're opposite in sign, so that looks like the best option. Okay, so we're going to multiply, alright, 3x minus 2y equals 18 by 3, and we're going to multiply 2x plus 3y is equal to negative 1 by 2. Right, so my new equations are going to be, here we go, 3 times 3x minus 2y equals 3 times 18. So this is going to be 9x minus 6y equals 54. So this is my new equation 3. And then I'm going to do 2 times 2x plus 3y equals 2 times negative 1. So this is going to be 4x plus 6y is equal to negative 2. And this will be my new equation 4. So step 2, we're going to add equations 3 and 4. So here we have 9x minus 6y equals 54, and we have 4x plus 6y equals negative 2. So when I add these two together, I get 9 plus 4 is 13x. I get negative 6y plus 6y is 0y is equal to 54 plus negative 2 is 52. So what I really have is 13x is equal to 52. So x is going to be 52 divided by 13, which comes out to be 4. Okay. All right, so next, step 3, we're going to substitute, right, x equals 4 into the equation. Now let's choose one. So we look at our original equations. Let's see which one's going to be good to work with. Notice that we have a 2x here, but a 3y here. So I like the idea I don't have a negative to deal with, so I'm going to put it into equation 2. So I'm going to have 2 times 4 plus 3y is equal to negative 1. So I have 2 times 4 is 8 plus 3y is equal to negative 1. So 3y, if I subtract 8 from both sides, is going to be negative 9. So therefore y is equal to negative 9 on 3, which is negative 3. So our solution will be, so the solution set will be this point, which is 4, negative 3. Okay? Right, so that's how we do that particular kind of question. Right, in this next example, we'll look at the third kind of scenario that we could have. So we're going to use elimination method again to solve this linear system of equations. We have, this one will be equation 1, and this is equation 2. All right, again, we're looking for a way in which we can eliminate a variable. Notice that I have a 2y here and a 4y here. So if I was to take, so step 1, if I was to multiply equation 1 through by negative 2, I'd get a negative 4y. So step 1, we're going to multiply 1 by negative 2. So here's our new equation. So it's going to be negative 2 by x plus 2y on this side equals negative 2 by 3 on this side. So I get negative 2x subtract 4y equals negative 6. So there's my number 3. Right, step 2. We're going to add, all right, 2 and 3. Notice we take the one that we didn't change. All right, so it's going to be 2x plus 4. It doesn't matter which order you write the equations in. And we're going to have negative 2x minus 4y is equal to negative 6. So when we do this, we have 2 plus negative 2 is 0x. 4 plus negative 4 is going to be negative, it's going to be 0y again. So I've got 0x and 0y. And 6 plus negative 6 is 0 as well. So I end up with 0 plus 0 equals 0. Or in fact 0 equals 0. Now when is that true? Right, this is true regardless of the x and y value. Right, so x and y can be any real numbers. So what we have here, of the form, now we need to be careful what sort of form will these have. All right, now if we look at this and we come back up to our equations here, all right, notice that we could write x here as 3 minus 2y. So the form that they're going to have, if we come up here, is going to be 3 minus 2y would be the x value for every y value. So these are the ordered pairs of the form that we have, and there is an infinite number of solutions. Okay, and the solutions will have this form like this. Alright, so we can actually specify the kind of points that occur. So for example, when x is, when y is 0, for example, a particular point that satisfies the system of equations could be when y is 0 would be 3, 0. Okay, if you come up here and I put in here 3, 0, does this work? Well, when y is 0, then I have x is 3, which works. If I put it in here, I've got 6 minus 0, which is plus 0 is 6, so it works there. All right, what about when y is 1? So I'd have so particular points could include 3, 0. What about when you have y is 1? Then I'd have 1 for x, and I'd have, and we've got 1 for y, so 1, 1 also works. Okay, so notice when x is 1, and we have 2 times, and y is 1, we have 3 equals 3, which works. So we can actually look at the kind of points that we can produce, but this is the general solution here. An infinite number of solutions, right, will satisfy this set of equations.